Welcome everyone. Up until now, we calculated the probability of an event happening in a vacuum. But what happens if we already have some extra information? For instance, if I toss three coins, if we toss three coins and tell you that the first coin definitely landed on tails, how does that change your odds of getting at least two heads? It shrinks your sample space. Conditional probability measures the chance of an event happening given that another event has already occurred. Mathematically, it is the probability of both events happening divided by the probability of the condition that is already guaranteed. So, some key properties are given on the screen, right? Next is the multiplication theorem on probability. The multiplication theorem is just a clever rewrite of our conditional probability formula. Instead of finding the probability of one event given another, we are finding the probability that both events occur in succession. Think of drawing two cards sequentially from a deck without putting the first one back. The outcome of the second draw depends entirely on what happened during the first draw. Next are independent events. So two events are independent if knowing that one happened changes absolutely nothing about the likelihood of the other. For instance, if you toss a coin and roll a die, getting a head doesn't change your chance of getting a 6. If the joint probability of E intersection F equals the product of their individual probabilities, you have statistical independence. So point to note here is you don't have to confuse independent events with mutually exclusive events. Mutually exclusive events cannot happen at the same time, whereas independent events often share common outcomes, right? But they do not influence each other's likelihood. Next, moving on to the Bayes theorem and total probability. So now we reach the crown jewel of this chapter, Bayes theorem. Imagine you have a known outcome, say a factory item is found to be defective, and you want to trace it back to find the probability that it was manufactured by machine A versus machine B. This is called calculating reverse probability or a posteriori probability. So it is the reverse probability. We use the theorem of total probability to map out all possible ways the outcome could happen and then isolate the specific path we are curious about, which we want to know. So that is the Bayes theorem. Initially it will be little confusing, but if we do some problems based on that, it will be very easy. So let's move on to some examples and some problems which we can solve. So very basic problem is there. So we have to compute the probability of A given B. So and if probability of B is 0.5 and probability of A intersection B is 0.32. So the direct definition of conditional probability we can apply, and we can substitute the values and we can get the final answer as 0.64. So moving on to the next example 2. So we have to evaluate probability of A union B. So if and also it is given that 2 times probability of A equals probability of B equals 5 by 13, and probability of A given B is 2 by 5. So So from the given expression we can extract individual probabilities. So we get the individual probabilities, probability of A and probability of B. So again, using the conditional probability formula, we get that the probability of A intersection B we have to calculate first, so that we can use it for the probability of A union B. So it is 2 by 5 into 5 by 13 equals 2 by 13. 5 cancel out. So to calculate probability of A union B, we use the addition rule of probability. So probability of A union B is your probability of A plus probability of B minus probability of A intersection B, which we have calculated. So that is, we can substitute the values very easily, make the common denominator, take the LCM, and we can get the final answer as 11 by 26. So the example 3 is, the problem is given. This is very simple. Probability of A is 3 by 5 and probability of B is 1 by 5. So we have to find the probability of A intersection B if A and B are independent events. So the solution is, since A and B are independent, we can apply the multiplication rule simply. So it is just the multiplication of probability of A and B to calculate the probability of A intersection B. So 3 by 5 into 1 by 5, that is 3 upon 25. That is the final answer. This was a very simple problem. So that we can solve a lot of problems based on these concepts. So thank you for watching the video. Like, share and subscribe, and comment if you have any doubts.